In this question, you are given the reaction of hydrogen cyanide reacting with oxygen to produce water, carbon dioxide, and nitrogen gas. You are also given thermodynamic data. You then ask two questions, the first of which is, what is the value of delta G naught at 298 K? There are two equations we could use. Delta G naught equals delta H naught minus T delta S naught, or delta G naught of the reaction equals the summation of the delta G naughts of the products minus the delta G naughts of the reactants. Since we're not given any of the delta G naughts for any of the chemicals, we can't use this equation, so we're going to have to use this equation. We're not given the delta H naught or the delta S naught for the reaction, but we do know that the summation of the delta H of the products minus the summation of the delta H of the reactants equals the delta H naught of the reaction, and the same setup works for entropy. So for the enthalpy, you plug the values in, you get a delta H naught of minus 2,574.8 kilojoules. Do the same for the delta S naught, and you get a delta S naught of 138 joules per Kelvin. Now we know we're going to be adding them, so we have to have the delta H naught and the delta S naught in the same unit, and for these types of questions, convert the delta S naught into kilojoules. We're back to delta G naught equals delta H naught minus T delta S naught. Plug in the values, and you get a delta G naught for this reaction of minus 2,533.7 kilojoules. The second question asks, is this reaction thermodynamically favorable at 298 Kelvin? Justify your answer. The answer is yes. The delta G naught is negative. If the delta G is negative, the reaction is thermodynamically favorable, QED.